All right, hello everybody. This is part two with Lewis dot structures. Okay, so we showed how we can take Lewis dot symbols, put them together to make structures. So we want 8 electrons around central atoms, 8 electrons around every atom except hydrogen, which is 2 electrons, and we have seen pairs of electrons be shared between 2 atoms. So one pair of shared electrons, or 2 electrons, is a single bond. But sometimes atoms can share more than one pair, just to help satisfy their octet rule. And these are stronger bonds because they're sharing more electrons. But if 2 pairs are shared, or that is 4 electrons, then we call that a double bond. And if a single bond is just like a line between 2 atoms, a double bond is 2 lines, which would be 4 electrons. And 3 shared pairs, or 6 electrons, is a triple bond, right? 6 electrons. So here are some examples of Lewis dot structures with double and triple bonds, and I'll help you to build it, but we can see the final result here. So here in A is a double bond between the carbon and the oxygen. This is a formaldehyde covalent compound, and the only way that the correct number of electrons can be around each atom is if oxygen and carbon are sharing 4 electrons. Now notice carbon still has 4 bonds, right? And 0 non-bonding. And oxygen has 2 bonds and 2 pairs of non-bonding. So just as we would expect, but it's just put together differently. So before we look at the triple bond, let's focus here on formaldehyde. So carbon has how many valence electrons? 4, right? Oxygen has how many? 6. And hydrogen has 1. And we have 2 hydrogens. So this has a total of how many electrons? It has 12 valence electrons, right? And so carbon starts out like this, and we can see that each hydrogen can come along quite nicely and give up 1 to share, and then oxygen, which would be like this, and with its 6 has a nice pair to share. But at this point, how many electrons are around carbon? 1, 2, 3, 4, 5, 6, 7. And oxygen has 1, 2, 3, 4, 5, 6, 7. So they each need 1 more. And this right here, these 2 can be shared, right? So then we'd end up with 4 electrons in between them. And we call that a double bond. Okay. We're going to work through these steps in a very systematic way in just a moment. But first, let's take a look at how we might end up with a triple bond. So nitrogen, this is N2, right? So a nitrogen has 3 single electrons and 1 pair. I'm going to use a different color. Right, and so we can see them, imagine them like lining up here, approaching each other, and they each need three more. to make their octet. And they each happen to have 3 alone, so they can share all of them, and we can reduce this to something like so, where these 3 lines are 6 shared electrons, right? So nitrogen is still happy, got 8 electrons around each one. 6 of them are being shared, and each has 1 non-bonding pair, which is again what we expect, right? This slide, that carbon makes 4 bonds, nitrogen would make 3 bonds with 1 non-bonding pair, oxygen makes 2 bonds with 2 non-bonding pairs, and halogens and hydrogens each make 1 bond. All right, let's take a question here. How many valence electrons are present in PCl3? So total valence electrons. You can pause it and come back. So one way to think of this is we can just write out everything, right? So phosphorus has 5, chlorine has 7, and we have 3 of those, so it's 21. So a total of 26 electrons, which would be D. Okay, so now we have PCl3 with 26 electrons. Draw the Lewis structure for PCl3 and select the correct description of the central atom. So let's do this one together. We have PCl3, and we can already make a prediction. If we look at phosphorus in the table, it should have 3 bonds, 1 non-bonding pair, and chlorine should have 1 bond and 3 non-bonding pairs. So this is our prediction. And we should be able to put it together to make that happen. So phosphorus is just like nitrogen. One thing you'll notice is going down a group, they are completely interchangeable. You can replace nitrogen with phosphorus and the structure is exactly the same. All right, and then Cl3. So each Cl has 7. So notice how it's kind of like hydrogen, just had the 1, but chlorine has these extra ones here. So each chlorine would come with its 7 and share 1 of them with phosphorus, making those 3 bonds. So we draw this with a lot of dots left over. Like so. All right, so now let's look at the central atom. It has 3 bonds and 1 non-bonding pair, like we predicted. And the chlorine has 3 non-bonding pairs and 1 bond. So back to the question. All right, so we find 3 single bonds and 1 non-bonding pair. Again, we could have known that from looking at the table, but we always want to check it, right, and make sure we confirm it ourselves. Okay, we'll stop here, and in the next part, we will actually walk through steps of drawing molecules as given in the guidelines on page 105.